Let's take a look at section 4-5, sample problems, and we'll start in the textbook on page 172, and we'll begin with exercise number 6. So what we're to do in these exercises is state the complement of the given event, and then find the probability of the complement of the given event. So in number 6, we have no girls. When a couple has 5 children, none of the 5 is a girl. So, and we're told to assume that boys and girls are equally likely. In other words, they have a probability of a boy is 1/2, probability of a girl is 1/2. So the couple has 5 children, and we're given no girls in this case. So the complement would be at least 1 among the 5 children. So that would be 1 minus the probability of no girls. Okay, and if we think about this, in order for it to be no girls, we'd have to have 5 boys. And the probability of each child being born a boy is 1/2. So we get the probability of all boys would be 1/32. Okay, and so 1 is 32 32nds. Okay, so that would be our probability, and here's our complement right there. Okay, and number 8, we're when 4 digits between 0 and 9 inclusive are randomly selected with replacement for a lottery ticket, none of the digits is a 7. So again, none, the complement is at least 1. At least 1, 7. 1 minus the probability of no 7s. So in this case, there's only 1 7 out of the 10, so if we're not getting a 7, that means we have 9/10, and we have 4 different numbers we're selecting, so it would be raised to the 4th power. 9 raised to the 4th, oops, turn my calculator on. 9 raised to the 4th is 65, 61 over 10,000. Okay, so alright, so I'm going to do this as a decimal. Last one I did as a fraction. Minus 656,656,1 divided by 1,000. 10,000. Okay, and I'm getting 0.3439, so that would be 0.344. So there's our probability, and there's our complement. Alright, at least one working calculator. Statistics student plans to use the TI-84 Plus calculator on her final exam. From past experience, she estimates that there's a 0.92 probability that the calculator will work on any given day. Because the final exam is so important, she plans to use redundancy by bringing 2 TI-84 Plus calculators. What is the probability that she will be able to complete the exam with a working calculator? Does she really gain much by bringing a backup? Alright, so looks like we're working on just a regular problem here. We don't have to worry about the complement. So we want the probability. She'll have a working calculator. So that's the probability at least one works. And that would be 1 minus the probability that neither work. So none of them work. Alright, so the probability any calculator doesn't work is 0.08. And she has 2 of them. So we have 1 minus 0.08 squared, 0.9936. So that's about 0.94. So the probability she has a working calculator has gone from 0.92 with one calculator to 0.994 with 2 calculators. So it's increased by about 7%. So I suppose that would be a substantial improvement. Okay, number 12. If you make random guesses for 10 multiple choice questions, each with 5 possible answers, what is the probability of getting at least one answer correct, given that the first 9 answers are all wrong? Okay, if we know that the first 9 answers are all wrong, doesn't matter whether they're right or wrong. When you're looking at a single question, you're just looking at the probability for that single question. And in other words, these are independent answers. So the probability is not affected by what happened in the first 9 questions. So all we have to worry about is the fact that there are 5 possibilities. So we want the probability of getting the last one correct. Okay, so probability last one is correct would be, there are 5 answers, only one is correct. Okay, let's move on to number 16. According to FBI data, 12.4% of burglaries are cleared with arrest. A new detective is assigned to 5 different burglaries. What is the probability at least one of them is cleared with an arrest? Okay, probability at least one. Would be 1 minus the probability that none are cleared. So we have 5 cases. Probability of clearing is going to be 1 minus 0.124, so 0.876. Actually, that's the probability they're not cleared. Probability of clearing is the 0.124. So I said that incorrect. So we have 5 cases. So we want to take 1 minus 0.876, and that is raised to the 5th power because there are 5 cases. So 0.8588 would be 0.859. Let me look at that again. 0.58. Oops, I entered the wrong number there. Let me go back. 0.876. Hit the wrong key. Raised to the 5th. So that's 0.484. Oh, that looks wrong. Okay, 0.4841 would round to 0.848. What is the probability that the detective clears 5 burglaries with arrest? Okay, so in part B, it's 0.124 raised to the 5th. 124 raised to the 5th. And that's 2.93 times 10 to the negative 5. Part of that one, which is 0.1234293. What should we conclude if the detective clears all 5 burglaries with arrest? He's a great detective. Would probably be my conclusion, assuming that the cases are no easier than the average case. Okay, 26. We have a table at the top of page 174 we're using with this. This is about fraternal twins. After having a sonogram, a pregnant woman learns that she will have twins. What is the probability that she will have fraternal twins? Okay, as I look at the table, I see 30 cases. If I add up, there are 6 5s, so if I add them up, I get 30. So the probability she will have fraternal twins and 5, 10, 15, 20 is 20 out of those 30, if I add up all the numbers in that row, which is 2/3. Alright, after studying the sonogram more closely, the physician tells the pregnant woman that she will give birth to twins consisting of 1 boy and 1 girl. What is the probability that she will have fraternal twins? Okay, so the only way to get 1 boy and 1 girl is if she does have fraternal twins, so it's certain that she will have fraternal twins, so that'll be a B. Answer B is 1. Okay, last one, redundancy in aircraft radios. The FAA requires that commercial aircraft used for flying in instrument conditions must have 2 independent radios instead of 1. Assuming for a typical flight that the probability of radio failure is 0.0035. Radio failure equals 0.0035. What is the probability that a particular flight will be safe with at least 1 radio working? Okay, so they're using 2 radios. Probability at least 1 works would be 1 minus the probability that neither one will work. So 1 minus 0.0035, that requires a failure on both of them. So 1 minus 0.0035 squared equals 0.999987775. 999 should be 4 nines. Okay, 8775. Okay. All right. So if we use our round off rule, notice what happened. If we use our round off rule, we'd round it to 1. Now, why does the usual rounding rule of 3 significant digits not work here? Okay, the problem with using the rounding rule here is that we're going to get a 1, which is certain that at least 1 will work. However, there's no guarantee